Welcome to EDU World Space.
Hello, this problem is about a squid and how it escapes a predator. So initially I'm giving that there's a squid and there's a certain amount of water in his cavity. So the mass of the water in the cavity is equal to 1.75 kilogram, and the mass of squid plus the water mass is equal to 6.5 kilogram. This means the mass of a squid is equal to the difference between these two, which is 4.75 kilogram. So this squid sees a predator, so immediately he will escape by expelling the water outside of his cavity with a speed v water after the expelling, so I'll put F for final, such that he will move in the opposite direction with a speed v squid final. And I'm giving this value to be 2.5 meter per second. It's worth mentioning that the initial speed is 0 as given by the problem. He was at rest. And the question is asking me in part A, what is the speed of the water need to be expelled from the squid such that he will escape with a speed of 2.5 meter per second? And the second part of the problem is to find the total kinetic energy that is made by the squid. This is a type of a collision problem. It is more like an explosion, but we still can think about it like a collision. One thing I want to bring to your attention is to figure out the number of particles or objects in the problem before the explosion or before the expelling and after the expelling. So number of objects, initially we have a squid, and inside squid cavity there's some water. So together they are one physical system. Whereas finally, after the expelling of the water, we have the squid and the water expelled as two different objects. So we have number of particles after the expelling is 2. As long as the initial particles and the final particles are not equal to each other, immediately should tell you this is an inelastic collision. And this means the conservation of energy cannot be used in this particular problem. And that's because it is an elastic collision. Okay. So what is conserved here? What can I use? Let's go to the next page. Well, remember momentum is conserved. So momentum initial equal to momentum after the collision. And momentum usually momentum is a vector, so we can put a vector sign here. I want to remind you that I need to choose a direction to be a positive direction. So I will choose this one here to be my positive direction. So the water speed going to be in this direction. This means going to be having a positive momentum, and the squid going to move in the opposite direction. This means he can have a negative momentum. So initially, I have the squid, squid plus water. They are one object moving with the same speed, the initial speed. Yes, I know it's 0 for this problem, but I will write it to begin with. Equal to the mass of the squid, velocity, speed of the squid final, and we know it's going in the opposite direction of my positives. It's going to be a negative value here, plus the mass of water V of water final. Again, initial speed is 0, so this is 0 here. And when I solve for the speed of the water final, so I'll get V water final equal to mass of squid over mass of water times the speed of the squid after the expelling. And I do have each one of these masses, both of these masses, and I have the speed, so squid speed, sorry. So mass of a squid is, we figure out to be 4.75 kilogram. And the mass of water expelled is 1.75 kilogram times the speed of the squid, 2.5 meter per second. When you plug in these numbers to your calculator, you find that the value of the speed of the expelled water to be 6.79. And don't forget the units, meter per second. Alright, so to check our answer if it makes sense or not, first let's check the units. Yes, we have meter per second is for the unit of the speed, and it is the correct unit. Second is that the mass of the squid is bigger than the mass of the water, so I expect the speed of the squid to be higher than the speed of the water, especially that initially they are at rest. So let's see if our speed here indeed bigger than the 2.5 meter per second for the squid speed. So this answer so far makes sense. So for the second part of the question, part B, where he's asking me to find the total kinetic energy created by the squid. What do I have here? First, the squid expelled the water. This means he made the water inside of his cavity to move. So there's a kinetic energy of the water, half water v water after the expelling, squared here, plus this expelling of water created a speed in his own body, which take a kinetic energy of half mass of the squid v squared after the expelling of water squared. Now we have all the masses. We are giving the speed of the squid. We just figured out the speed of the water. We have all the information required in this formula. And if you plug it all in, you should get a value of 50.2 joules. Always remember to put the units. And here it is. Here's the solution. Hopefully you enjoy it. Hopefully it made sense to you. Let me know in the comments. And take care. Bye now. Bye.